Change is the only constant in today's world of information technology, and data centers are no exception. There is an unprecedented demand to onboard new applications and services with a high level of agility. And on the other hand, application owners expect a five nines of availability. Networking people like you and I are in a fix. How can we make changes in our network without impacting application traffic? In comes Enterprise SONiC. Due to its unique architecture and toolset, Enterprise SONiC can provide a solution to this problem. Well, I said a solution. There are in fact three distinct solutions that Enterprise SONiC can provide in this regard. Option number one is container upgrade. Because SONiC has a microservices based architecture, it gives you the capability to upgrade or patch one particular feature without impacting any other service or protocol running on your operating system. A very good option if you want to patch one particular feature like VRRP or DHCP relay and so on. Option number two, warm reboot, which is SONiC's implementation of hitless software upgrade. So you can upgrade whole operating system without having any impact to the data plane. And option number three is maintenance mode. So I will create separate videos for option number one and option number two, but in this video, we will focus on maintenance mode. So what is maintenance mode? Maintenance mode is a mechanism to gracefully isolate a SONiC switch from the network in order to perform some maintenance activity. So for example, if we want to carry out a maintenance activity on spine 1 in this diagram, maintenance mode can provide us tools to isolate it from data forwarding path. Once isolated, now we can carry out our maintenance activity like software upgrade or security patching without impacting application traffic. Please note that maintenance mode will only provide a 100% hitless software upgrade in a well-designed and redundant topology. For example, having multiple spines and dual attached hosts. So how does it work for spine? Since spines only connect to leaf layer, this isolation can be carried out by route biasing via routing protocol. Which method you will use depend on what underlying routing protocol you are using. So for example, if you are using OSPF as underlay routing protocol, you can configure your switch, the one you want to isolate, to advertise LSA with maximum metric. All OSPF peers will remove this switch from the forwarding path. A similar technique is available with BGP, where you can advertise a verse med value. But the technique I'll use in this demo is the third one, using a well-known BGP community called graceful shutdown. It's simple to configure and works very well. We'll see in a minute. Moving on to leaf. So now, will the same method work for leaf isolation as well? Answer is yes, it will work, but no, it won't be sufficient. Why? Because leaf is connected to two distinct type of devices. On the north side, through the uplinks, it is connected to spines. So on this side, it is using routing, and we can do the isolation using the same route biasing technique or BGP graceful shutdown technique that we just talked about. But what about the downlinks? Here on the downlinks, leaf switches are typically connected to servers or service devices like firewalls or load balancers or external routers. If these are layer 3 routing devices, for example, it's a firewall and you're running routing with it, or if it's an external router, you're running routing with it, once again, route biasing will work. But what about the most common connection, which is the MC lag connection with a dual attached host? How does isolation work in this case? Here we have a very good technique called port channel graceful shutdown. Port channel graceful shutdown relies on LACP messaging and it works like a charm. We will see in a minute. So here is all the configuration you need. Yeah, just one command, graceful shutdown or BGP graceful shutdown. Obviously, you will issue this command in the routing configuration mode. And once again, one single command for the port channel graceful shutdown. This command is issued in the global configuration mode. So let's start our demo. This is my lab topology. We have 2 spines and 3 leaf switches. They are all running Enterprise SONiC version 3.1.2. And I've got these endpoints here. I'll be using endpoint 10.1.1.1, endpoint 1 with this IP, and server with IP of 11.1.1.50. Communication, the traffic is already flowing between these two endpoints. I am running VXLAN EVPN in this topology, and BGP is used as my underlay as well as overlay routing protocol. Now, in this demonstration, I will be showing you spine isolation as well as leaf isolation. And our success criteria will be that when we isolate a switch which is in the active forwarding path, when we do this isolation, there should be no traffic drop during the process. As you can see, this is my server, display of my server, and you can see the traffic is ongoing. At the moment, there is 0 packet loss, and we expect to see similar result after we have successfully done the switch isolation. So let's start with the spine. First thing is for us to identify is that which of these spines are in the active forwarding path. So traffic is coming from the server, it is hitting one of these spines and then getting to one of these leaf 1 or 2 to get to its destination. How do I check that leaf 3, that whether leaf 3 is forwarding this traffic on Ethernet 48 or Ethernet 72? Well, you can say that, you may say that, I can do a show IP route on leaf 3 and look at the routing table. It's not going to help. So let's have a look at it. So leaf 1 and leaf 2 are logical VTAP. So leaf 3 will be forwarding traffic to this logical VTAP IP 100.1.1.1. And you can see that for 100.1.1.1, leaf 3 can reach this IP using these two paths, Ethernet 48 and Ethernet 72. Ethernet 48 means spine 1 and Ethernet 72 means spine 2. Looking at this display, I cannot tell which path will be used because I am using BGP multipath. So we are load balancing across both the links. What can help me in this case is this show interface counter command. And I don't want to look at all the interfaces, so I will grep for the specific interfaces. So I will look for interface Ethernet 0, where this traffic is coming from and being sent out. And I will look at interface at my uplinks 48 and 72. So this is Ethernet 0. Obviously, we are receiving traffic and transmitting traffic. Let's have a look at Ethernet 48. So I'm not receiving traffic from spine 1, but I'm transmitting traffic to spine 1 from leaf 3. So leaf 3 is not transmitting traffic to Ethernet 72, which means spine 2, but it is receiving traffic from spine 2. What does it mean? It means that the outgoing traffic, it hits leaf 3 forwards it to spine 1, and then through spine 1 it gets to the destination. Return traffic hits spine 2 and then gets to leaf 3. So any of these leaf will work. They're both in the forwarding path. Let us isolate spine 1. So let's go to spine 1. I like to work in SONiC CLI mode. And we know the command here. We'll go to BGP mode. router BGP 65001, and very simple command, graceful shutdown. Graceful shutdown. Now, before I enter, let me see, ping are ongoing, and on leave 3, show IP route. At the moment, you can see that leave 3 uses both spine 1 as well as spine 2 for traffic forwarding. This is going to change. So on spine 1, we say graceful shutdown. Let's see any traffic loss here. No, traffic still flowing. And on leave 3, if I do show IP route, I can only see one path to get to 100.1.1. That is Ethernet 72, which means spine 2. So now leave 3 does not use spine 1 for traffic forwarding. It has been removed from the forwarding path. Why that is the case? Show BGP IPv4 unicast, and let's look at what routes I am receiving for 100.1.1.1. Is spine 1 not advertising routes anymore? We are receiving multiple routes. We are receiving 2 routes, right? One from 0.4, this is the loopback IP of spine 1, and one from 0.5, spine 2. So spine 1 is still advertising it, but here is the key thing. Graceful shutdown community. Spine 1 is advertising all the routes out with this community of graceful shutdown, and that is why any BGP speaking router, when it receives a route with this community, they will not use this route for traffic forwarding. And that is why we only see one path to get to the destination. We are not using spine 1. So we have now isolated spine 1. I will validate that by this command, show interface counter rate, and you see that we're not receiving any traffic. Yeah, well, there are some packets which is packet per second, which is BGP and BFT, but no data forwarding. So now spine 1 has been isolated from traffic path in a graceful manner, and we can carry out our maintenance activity on spine 1. If I, on my server, if I stop the ping, you can see 0% packet loss. So without any packet loss, we gracefully isolated spine switch. Okay, now let's move on to leaf isolation. So remember I mentioned for leaf, we have to cater for 2 different type of devices. Leaf is connected to spine 1 and spine 2, as well as it's connected to the endpoints. So let's first start with the endpoints. We will focus on endpoint 1 and leaf 1 and leaf 2. I'll see if leaf 1 is in the active forwarding path. If it is, then I will isolate leaf 1. Leaf 1, same command again, show interface counter rate, and I will grep for interface, and then I'll grep for Ethernet 0, 48 and 72. Not receiving traffic on Ethernet 0 and not forwarding traffic to see Ethernet 0. So not a good example. Let's go to copy the same command, and let's go to leaf 2. Okay, from here, yeah, that's more like it. So on leaf 2, we are receiving traffic on Ethernet 0. So this is Ethernet 0 on leaf 2. So it's receiving traffic on Ethernet 0 from endpoint 1, and it is transmitting. So both transmit and receive is happening through leaf 2. So leaf 2 is a very important switch. When we will isolate it, we'll see if if I just shut down this port, or if I reload leaf 2, we will see maybe a couple of traffic ping loss, right? But with the maintenance mode, with the graceful shutdown, we should not see any traffic drop at all. On leaf 2, this is port channel 1, show port channel 1, sorry, show port channel summary is the command. So this is my port channel, and on my endpoint, this is endpoint 1, command is slightly different, show port channel 1. So 1/0/1 and 1/0/2, they are part of the port channel bundle. I will issue port channel graceful shutdown command, this command on leaf 2. When we issue this command on leaf 2, what's going to happen is that leaf 2, the LSCP process on leaf 2, the LSCP state machine will stop. And before that state machine is stopped, leaf 2 is going to send an LSCP packet with its state bits reset. So state bits are 3 bits in an LSCP packet, the synchronization bit, collecting bit, and the distributing bit. When these bits are set, it will tell the other side, in this case endpoint 1, that leaf 2 is not ready for bundling, for making a port channel, and it will remove port 2 from the port channel bundle and will only use port 1. So in this command, once we issue the when we shut down the port channel, graceful shutdown, we will see that this port should be removed from the port channel. It should say failure. Okay, so this command is issued in configuration mode, port channel graceful shutdown. Before I issue that, let's have a look. Ping is still ongoing. Stop and start again. So 0 packet loss. Okay, and leave 2 done. Come to endpoint. Now you see the endpoint has removed 1/0/2 from the forwarding path. Did we lose any traffic? Answer is no. So we gracefully removed this port without losing any traffic at all. And now if I run that interface counter command here, there we go. We're not receiving anything on Ethernet 0, obviously. Yeah. What about leaf 1? Any change here? Absolutely. Now leaf 1 is being used for receiving as well as transmitting traffic on Ethernet 0, which means that this is in the active path. Leaf 2 was removed without any traffic loss. What about 48? Yes, it's down. And what about 72? So you see, I'm still receiving some traffic on leaf 2. Ethernet 72, what is that? Ethernet 72 connects me to spine 2. So why spine 2 still forward traffic to leaf 2? Answer is because on this side, for the uplink side, we have not done any graceful shutdown. So leaf 2 is still in the forwarding path as far as spines are concerned. If we want to remove that, we will need to do something about it. And what we will do? We will do the BGP graceful shutdown. So if I now go to spine 2, you will see that spine 2, show IP route, you'll see that spine 2, and we are talking about 100.1.1 here, right? So spine 2 has two paths to get to 100.1, Ethernet 0 and Ethernet 4, and it is using Ethernet 4. Once leaf 2 has done the BGP graceful shutdown, we will see that this path should be removed. Okay, leaf 2, router BGP 65.101. What is happening? Router BGP 65.101. BGP is running with AS number. What's going wrong here? Okay, working now. So 65101, and command will be graceful shutdown. Done. Let's go to spine 2 for verification. And you can see that now it's only one path to get to 100.1.1, Ethernet 0, Ethernet 4 has been removed. So now we have successfully isolated our, not leaf 1, sorry, leaf 2. We have successfully isolated leaf 2. We'll verify it with this command. I'll just show it again. Leaf 2 and show interface counter rate. I am interested in Ethernet 0, 48 and 72, and there we go. No traffic at all on any of these interfaces. So definitely leaf 2 is now isolated and we can carry out our maintenance activity. And what about the traffic? 0% packet loss. So we can see that in this case, maintenance mode keeps its promise. Maintenance mode allows us to gracefully isolate a switch, whether it is spine or leaf, from the active traffic forwarding path without causing any disruption to the end user traffic, and it allows us to carry out any maintenance activity on our switches. Thanks for watching this video till the end. If you have any questions about maintenance mode, please ask in the comment section. Otherwise, we'll see you in the next video.